Hi everyone, this is week 4, day 4, video 1. Now recall, we looked at limitations of sine law. So it was not very useful in solving triangles, say, where all three sides are known and the three angles are unknown, right? There were a couple of scenarios where sine law was not useful. And I mentioned we will be learning something called the cosine law instead. So, well, we have these two scenarios where sine law is not applicable. So let's get back to the drawing board and we have an oblique triangle. So it's the same story. Label them A, B, C, and we start with what we know, which is we build right-angled triangles. But now, since we've already done what we can do with sine, now let's look at the ratio cosine. Now, however, if let's call this triangle ADC. If I look at cosine of A, I need somehow a way to label the adjacent here. So what I'm going to do is I'm going to call this x. Remember how for sine we used h, right? Which I'm going to use again still. Now if this is x and this entire length is c, then what remains is c minus x. So cosine A is x over b, and in triangle DBC, cosine of b is c minus x over a. Okay. What this gives me here is that okay, these are my ratios that I have here. So let's store them aside. And we're going to use another tool that we have learned in this course called the Pythagoras Theorem. Now if I apply Pythagoras Theorem to triangle ADC, I get that x squared plus h squared should equal b squared, or that h squared is b squared. Sorry. Right, x squared plus h squared is b squared, and in triangle CDB, c minus x squared plus h squared is a squared. Now from here, from the ADC, I have h squared is b squared minus x squared. So let's get rid of this h squared. I plug this in there. I get c minus x squared plus b squared minus x squared is a squared. Now I FOIL this out to get c squared plus x squared minus 2cx plus b squared minus x squared equals a squared. So the x cancels out, and what I get is a squared equals b squared plus c squared, kind of looking like Pythagoras, but minus 2cx. But this x I can use here. X is nothing but b times cosine A. So I get this relation, a square equals b square plus c square minus 2 times c times b times cosine A. And this is called the cosine law. There are no h or x's here, right? So it depends solely on the sides of the triangle. It looks complicated, but there is an inherent symmetry in it, so it's very easy to remember. The symmetry is, well, it looks like Pythagoras, right? So when you have a squared, you have the remaining letters, BC here, and then you have BC here, and this angle corresponds to this side, A. Which means, symmetrically writing, B squared would be a squared plus c squared minus 2ac. So these are all a and c things, cosine of this letter, so B. and c squared would be a squared plus b squared minus 2ab cosine of this letter, so c. And that's called the cosine law. Now here you can see the scenario that we were not able to solve with sine, where lowercase abc are known, can be solved because then I know c, a, b, I know this, and there's only one unknown. Anyways, it will make more sense when we look at an example. Find sine x here. Now let's try to apply. So recall, what is this case? You know two sides and you know the angle contained in that side, right? So that was, if you recall, this case. Two sides, the angle contained in them given, we said we cannot use sine law. But we can use cosine law, right? So x squared is going to equal the other two sides squared, right? 5.900 minus 2 times these sides that you know, cosine of the same letter. What's opposite angle x? 31. So it's cosine of 31. Now from here there are two methods of solving this on the calculator. First, you plug in this thing exactly as it looks. 6.300 squared using the square button here, plus 5.900 squared minus 2 times 6.300 times 5.900 times cosine 31, and you press enter. You get a number. But remember, this number is not x, it's x squared, right? So x is actually the square root of whatever you get here. So what you can do here is, your calculator will have this button called ANS for answer, and it will be one of those for which you have to use the second key. So what I can do is, and I need to take the square root. Now right above the x square button, there's a square root symbol. So you go second, that gives you square root, second, that gives you answer. Enter, that would give you x directly. The other method is to write everything under the square root. So I start with the square root and I go 6.300 squared plus 5.900 squared minus 2 times 6.300 times 5.900 times cosine of 31. But I have to remember to close the parenthesis for the square root. Okay, and gives me the exact same answer. Now in my opinion, the first method is less prone to errors. So you find the whole expression and then you use square root of answer to find the value. Okay. Now we're going to look at an example where we'll have to use inverse trig to find angles. Using cosine law, show an equilateral triangle has all angles equal to 60. Now we already know what does an equilateral triangle mean. All sides are equal, all angles are equal, so they have to add up to 180. Only possible way is if they are all 60. But this is just for practice, right? Now we don't have any dimensions here, so I'm going to go ahead and I'm just going to call all of them A. Actually, let's call them X so there's no confusion. And I'm going to call these angles A, B, and C. So I'm going to solve for one of them. So let's say x squared will be equal to x squared plus x squared 2 times x cosine of A. That's my unknown. Right? So this is x squared equals 2x squared minus 2x squared cosine A. I subtract 2x squared on both sides. negative x squared 2x squared cosine A, divide by negative 2x squared, divide by negative 2x squared, cancels out, the negatives cancel out, x squared cancels out, 1/2 equals cosine A. So A is going to be cosine inverse of 1/2, which, as long as your calculator is on degrees, should give you 60 degrees. Now obviously this equation is not going to change even if I replace this by b or c, because all sides are x, so it's always going to be 60 degrees. Now if this method with the x, well, the x method is more general because it shows for any equilateral triangle. But if you get confused in the steps, you can try with x equals 1, 2, 3, and you'll observe that the same thing happens, because eventually whatever the x things get cancelled out, right? So they don't matter. All right, let's do one more, and then I'll do the remaining in the second video. Find angle DEF. So this is a scenario where 3 sides are given and you have to find the 3 angles, and it's not equilateral, right? Okay, so let's say for labeling purposes, call this E, F, and D. Now, what I can do here, are 2 ways of going about it. You can just plug into the equation and solve, but you can also sort of rearrange the terms on the equation. This is what I mean. Now, in this particular form, I'm assuming that this is my unknown, right? So I can just solve. But what if I need to find this? Then my goal would be to isolate cosine A. Yeah, that's about solving equations. All right, how do I isolate it? I add 2bc cosine A to both sides, right? So that this cancels out. So now I have A squared plus 2bc cosine A equals b squared plus c squared. Again, keep in mind I'm isolating or trying to isolate cosine A. So I get rid of this A squared. Now I have 2bc cosine A equals b squared plus c squared minus A squared. Finally, I need to get rid of the 2bc, which I can do by dividing the thing. So I get cosine A equals b squared plus c squared minus A squared over 2bc. So if you do this beforehand, it saves you a lot of pain when you are trying to find angles here. Because now I can just use this relation here. For example, if I want to find angle E, then cosine of E is going to be, so A means I start with B and C. So the others here are, other letters are D and F. So this is going to be D squared plus F squared minus, what I subtract corresponds to the same letter. So E squared 2 times the other letters, D, F. Now it comes down to plugging it. Now here, because of the division, addition, subtraction, you wanna, when you put this in the calculator, you wanna use parentheses. Okay, let's go ahead, and plug that in. Discard that. Okay. Now in my labeling, D is this guy. So I give a parenthesis for the numerator. 14.8000 squared plus F squared. I identify F as this one. 7.6000 squared minus E 10.6000 squared, and I close my parenthesis. Now that's my numerator, so I can write divide, and let's put this under parenthesis just for good practice. 2 times d, which is 14.8000, times f, which is 7.6000, close the parenthesis. Okay. Now again, like in the previous example, this value is cosine of e, not e, right? E is going to be cosine inverse of whatever this gives you. So the best way to do that, so that you don't have to copy all these numbers, is using the answer button. So I go second, cosine inverse, second, answer. What answer does is, whatever value you just calculated, it stores it there. You press enter and you get E is 43.03 degrees. Now this looks like a complicated process, and it is, but the nice part is you only have to do it once. Why? Because now that you have this angle, you can use sine law. Now you can use sine law, because now you have 10.6 over sine of 43.03 equals 14.8 over sine d equals 7.6 over sine f. So if I use this equation, I know 3 things, so I can find d. Once I find d in this equation, I will know 3 things and I can find f. So try complete this. Find d and f. In fact, there's a further shortcut here. You use sine law, find d. If you have d and you have e, you can just find f as 180 minus d minus e. So in the case where 3 sides are given, all you really have to do is apply cosine law to find the first angle, sine law to find the second angle, and then 180 minus to find the third angle. Okay, this video has gotten really long, so I'm going to stop here and then do the remaining examples in the next video.